I'm talking about conditional aces and claims and what they do, as far as I know. I was hoping to have Joseph Sutton here also talking about it, but he's in New Zealand. He was a little bit too wise to come this far. And I was also meaning to ask him lots of things before I left about how the claims work, but I didn't get around to it. So I've had some help from Joseph, but when I get things wrong, it's my fault for not asking him. So conditional aces are aces. Aces are entries in an ACL. Most of you probably know this stuff. And usually they're based on SIDs. So if you're in the SID or whatever, you get denied or allowed, and that kind of allows a fine-grained kind of control of, you can, with lots of denies and allows, you can allow anyone and deny anyone as much as you like. You just need lots of groups. And so, but the grain is grain, so it's easy to split grain like this, but if you're trying to split things in a different way, like split things that are close to the centre, or you're trying to select things that have a certain luminosity in the grain, you can't really do that so easily with ordinary aces. Or you can make new groups, but then say you wanted to allow a slightly darker colour, whatever it is, this represents, the analogy is a little bit bad, but or if you want to combine them, so only things close to the centre with a certain luminosity, if you want to select things like that, if you had a conditional ace, you could make an expression like this without adding a whole lot of groups and doing annoying things like that. So that is one part of the use of a conditional ace, is to allow you to invent rules based on attributes. And where the attributes come from, that's where the claims come into it. But I'll get to that later. So now a conditional ace is a kind of a callback ace. So the reason it's called a callback ace is that in the Microsoft API, you can register, like a vendor, let's say a vendor can register a new kind of ace, a new kind of callback ace that will call a function as part of the authorization. So they call it a callback. What they really only ever mean, as far as I can tell, is a conditional ace. But in theory, like you could register something. Well, here's a normal ace. Okay, yeah, here's a normal ace. It's a normal simple ace. This one is saying deny to somebody, something to somebody, and a callback ace is the same structure, except rather than saying A or D there, it says XA or XD, and it's got like extra junk on the end, and the only way you know it's there is that the length goes further than the end of the SID. So that stuff down there is interpreted as the callback ace. And now how it decides what callback to do is there's some, starts off with a magic string. So like imagine you'd registered a new kind of callback ace that was based on the phase of the moon. You could deny things when the moon was in a waning gibbous state, which means it's fat but getting smaller. Then you could register this stdl syntax, and you could, this is what I'm guessing, because don't really care about the callback part of it, just saying this is what you could probably do. And then it would put some junk there, and then when it came along, it would read this, it would say, oh, I know that callback, that's a lunar cycle callback, and it would do the thing. But there's one built-in one, or you can turn it on, and that's the conditional ace. And its magic string is ARTX. And so if you've got conditional aces enabled, and it comes to like an XA or XD or some other weird ones, and it's got the extra stuff at the end, and it says ARTX, then it knows that it's the conditional ace. The other ones are kind of that aren't XA or XD, which is the conditional deny or conditional allow, kind of audity things, which might be useful, might be what is used when you're registering a callback, because I can imagine you might want to do that for an auditing kind of thing. Anyway, so this STDL is the syntax for a conditional ace, and here the condition is x equals 42, and that's a valid ace, and that is so that that compiles to this bit at the end of the ace, and this is like the decomposition of that stuff. So we have the magic number, and then there's this is saying that this token, this next few bits are a token for a local attribute, which its name is x. It's too long, so that even though the whole thing can only be less than 64k, you get a 32-bit length. The battery's getting flat on this. And then there's the Unicode name, and then well, this is like an infix syntax. The conditional ace is formed as a stack, which means that when you're reading it, the actual binary ace, everything just turns up at the time you want it. So you put on your arguments, and then you get your the operator, and you put the result on the stack. It works nicely once you've compiled it. And then this says it's a 42 is a 64-bit integer with that value, and then there's these weird magic things that the integers have, which are just flags to say how it's displayed. So this is saying it's not displayed with a sign character. If that was plus 42, you'd say that would say it had a positive sign. I don't know how it works if you've got a negative sign here and actually a positive value, because I don't know. And that's saying that it should be displayed as base 10. Like if you had a different number in this thing, it would be displayed as in hex when it was turned back into STDL. And then at the end, you have the equals part, and it just says, now if this is true or false, is this 42 or not, and how, or unknown. If there was no such thing as x, it would say unknown. So that there's a ternary logic, like a three-way logic, the true, false, or unknown. And it mostly works how you'd think. So when something is, if something's true, it survives being ORed against an unknown, because the worst case is it'd be ORed against a false. So it stays true. Whereas you have to have two trues to be true through the and of course, as everyone knows, not unknown is still unknown. And then if the end result of the whole expression is unknown, if it's a deny ace, unknown means yes. It means yes, deny. If it's a allow ace, it means no, don't allow. So it's like unknown results, you just treat them with as much suspicion as you can, and it works. But this X is called a local attribute, and I'm probably wondering where it came from. And I've just been working on conditional ACEs, and I haven't known this myself. I just thought, they come from somewhere. Turns out they come from claims, but I'll just put that aside for the moment. Let's talk about conditional ACEs a bit more. So these are the kind of examples that you find on the web. Probably I have every example you find on the web, because hardly anyone puts examples on the web. From the Microsoft Docs mainly. So like this has turned it around. So it's a deny ACE. So the D is saying it's a DACL. Then it's a conditional deny and some stuff, and then it's saying if the user's title is PM, deny access, right? So the project manager can't see. This is probably a useful thing. Actually, I think the example was the other way around. And then this one is saying if it's a project or PM, and they're in the finance division or the sales division. And now see, these are called user attributes when it's got the at user and user. At user. Wrong way. So this one is saying allow members of these SIDs, and they've got the device has got the BitLocker attribute true. So that's the device. What's the claim? What's a device claim really? Device attribute, and it's coming from somehow coming from the device. And that member of is actually talking about the object, I think. I'm a bit curious now. I have to think what that member of is talking about, whether it's the user or the authenticated principal or what. Now, the SID is, I think it always has to be this kind of SID, WD and S110, which means pretty much anything, I think. Is that right? And so now this one is saying the user project attribute can be any of the resource project list. So the resource project attribute can be more than one thing. Now with the resource attribute is not like the other ones, like the user and device. It actually comes from another kind of ACE, which I'll get to. Now this is a thing that you use in an authentication silo. And say you've got a silo called tier 0, which I've heard is the kind of silo you probably most likely want. Then this X authentication silo is like a magic attribute for the user that is computed from various other attributes that are all around the place. And if Joseph was here, he would know how to say how that works, because he's been working on the silo part of it. Or I haven't quite followed it, but a silo is a bit like a kind of a group where you can only be in one silo or another, and it produces this kind of claim saying which silo you're in, among other things. And now this one, user.clearance level is greater than or equal to the resource required clearance. That kind of indicates, I think, the customers that they're aiming for. Like agencies in the US where they have secret things with clearance levels and stuff like that. So, but that's the sort of thing you can do is by, you can change the clearance level on a resource, and you don't need to shift SIDs around to change who can see it, or make new groups or anything. It just kind of like, or someone can, the clearance level can go up and a whole lot of things appear for them. So it allows you to do things that you could do with groups, but maybe you get sick of it. These are the kind of operators you have. You have like various comparisons, and then and an or and not, and then most of these things sort of are self-explanatory. So the member of means the member of all, the device and the device member of, which you kind of learn, but because member of any means if it's given the list, if it's a member of any of them, member of any is true, but otherwise it has to be the member of all. And then they thought, well, we can put not on the beginning of all of them, even though we've got the not operator, we can save some time doing that. And then there's a composite lists, and there's logical grouping, so there's an order of precedence. So in the STDL, you need that thing. In the actual binary form, it all falls out of the way it's constructed. So here are the types that you've got to deal with. There's integers. Now in the conditional case, there's 4 different kinds of integer, but you can't access any of them in any way that, only one of them you can get to. The 8-bit and 16-bit and 32-bit, they're all encoded the same way as the 64-bit, as a 64-bit number, but they've got a different tag, and that tag, the only thing that changes is that if you can somehow construct the value to have a too high a number, it should fail. If it's greater than an 8-bit number. But the STDL, you can't express anything except the 64-bit one, and you can't get it as a result, as far as I can tell. So I don't actually know why they have those. I think the people who were writing conditional ACEs, they weren't talking to the people who were doing the claims stuff, because the types are all a bit different. The Unicode strings are UTF-16, of course, and then it's just like random bytes. And then there's a composite list. It can have nested things, and it can have anything in it. It's just like a list, except they're only ever used with the same types all the way through. So you can construct them like that with all these things, but I haven't found anything that would use anything but, say, a list of SIDs, or purely SIDs or strings or something. But anyway, and then there's the result type, which is like a Boolean with the unknown. Okay, and so the attributes are from claims, which I'll get to, that issued to the user or the computer, or to a resource. And if they don't have this thing on the front, they're called a local attribute, and that just says the authenticated principal. And those, I think that might be an earlier part of it. They didn't really realise that they needed users and attributes, and because there's a whole different syntax about how the local attributes work. These ones can have pretty much any string in them, whereas the local ones are sort of like the kind of string you can have in a name you could use in C. A resource attribute comes from another new kind of ACE, and it's just called RA, at the beginning, and then it has to have all the colons in there, semicolons, and nothing except the SID, and the SID has to be the WD1. And then so it's got a name, a type, some flags which I don't know what they are, and then that list of values. And so all the values have to be the same type. And then so when that ends up coming through to the conditional aces, that will look like a list of values of the same type. But the types are different. You can have an unsigned integer, and yeah, anyway. And they come in the SACLs, the resource attributes. So you can have, I think, so if you had this conditional ace in your DACL, that would be the same as having this conditional ace in your DACL and that one in your SACL, because it's just referring to the resource, and the resource attribute is defined as the same thing as this, being a foo, an integer, no flags, of value 1, which is what you get there. But the DACL could be an inherited thing, so I think the reason you use a resource ace is so you can do that kind of thing, like have the DACL, the conditional ace somewhere else. So from the point of view of the conditional ace, the claims come from the security token, and what we have in Samba at the moment is we have our security token as a list of SIDs and some mask things. But what Windows has is a list of user claims, device claims, and local claims. And now the resource claims, they don't come in the security token, they come from the resource SACL. And then there's the device SIDs, which I think might be necessary or not, I don't know, but they're listed. So the claim object that you're dealing with, that from our point of view so far is just coming from the security token. It's got a name and a type and some flags, and then values, and they've got the same types as the resource ace, which is not quite the same types as the conditional ace, but they're close enough that mostly it won't matter. And then the security token claims come usually from a pack. And the pack is like a secure blob in the Kerberos ticket that, from the point of view of the claims, it's like a key values store that you can trust. It's got slightly different types again. I think it might have SIDs. Might have that wrong. Anyway, it comes from the KDC, and the KDC gets the things that it's going to put in the claims from LDB in our case. So this is a way of a little chunk of the database to be picked up and carried around with a Kerberos ticket. Attributes of the user or device or whatever. That's really all it is. A snapshot of values from the database that float away with the Kerberos ticket. Other things can look up stuff in the database without looking up stuff in the database. Something you don't really completely trust can make a decision about what it should do, and it doesn't need to read the database, or even just slow things down by looking stuff up. And as far as I can tell, that's basically the main point of a claim, is you can you tell the Kerberos ticket more stuff that other things can use to make decisions about authorization. If you didn't have Kerberos, you could do it. Like in TLM, you could if it found the conditional ACE, it could go and, if it had a way, it could go and ask the database and say, well, tell me about this thing. But I don't know if that's worth doing or wanted. But if it didn't work, it would either, if it was a deny ACE, it would just deny everybody, if it had no way of knowing, and an allow ACE, it just wouldn't allow it. It might fall through to another allow thing. So, for what reason? It's about the decentralization of complex authorization decisions, and that's what claims are for. And conditional ACEs are the mechanism by which they're evaluated in at least some places. So the claim could be used in other ways by other things, but it would amount to the same kind of decisions. And authentication silos involve magic computed claims which I don't understand. But the main reason one major reason we're doing it is that it gives us 2012. We can say we support some kind of 2012 R2 functional level. I can't remember if it's forest or domain and what kind of functional level it is. It's one of those. If you've got claims and conditional ACEs, you can tick that box, and ticking the box, after a while it becomes important in its own right. But I think they are actually interesting in their own right for the things they let you do. I was talking to Alexander the other day, he's not here, but he seemed to think they're a good thing, so that's good. Personally, I have just been, I'm going to go back, so I'll just finish my sentence before you can ask a question. I think I've gone fast, have I? Yeah, anyway. So I've been working on the conditional ACEs and not the claims. And that's really where I'm coming from. I don't have a use case for them, I just have a compiler for them.